Let's do an example where we're finding a partial fraction decomposition and we do see some repeated linear terms. So here our denominator is all nicely factored up for us. This will always be like our first step in a partial fraction decomposition is factoring our denominator. But we see that the x plus 1 linear term only shows up once. The x squared term is we can think of as x minus 0, and this is squared. So this is showing up twice. So our partial fraction decomposition will have one term for the non-repeated root, and then we'll have a term for each power of the x. Okay. Now our cover-up method is very useful, but it only applies when we have non-repeated roots. So we can use it to find the a term, but not b. Okay. So a here, we can get by evaluating our original expression where we leave off the x plus 1. We're going to be evaluating this at x equals -1. So we have 3x plus 1 over x squared. This gives us -3 plus 1 over 1, or -2. Now, to go forward, we are going to have to combine our fractions. So we have 3x plus 1 over x plus 1 times x squared. It's going to be -2 over x plus 1 plus bx plus cx squared, c over x squared. We're going to multiply both sides by this x plus 1 times x squared. Okay. So we're multiplying both sides by this denominator just to clear it out. Okay. So this gives us 3x plus 1 is equal to -2 times x squared plus bx times x plus 1 plus c times x plus 1. All right. Now, one point that's easy to evaluate at, we can let x equal -1. Whoops, that's not so helpful. If we wanted to find c, sorry, let's let x equal 0. Well, if we let x equal -1, we find this -2 equals -2. Okay, so let's let x equal 0. So we're choosing that because it's a 0 of these terms. And so when we plug it in, all that we'll be left with is c. Okay, so that tells us 3 times 0 plus 1 is equal to 0 plus 0 plus c times 1. So 1 equals c. Okay. All right. And so we have 3x plus 1 is -2x squared plus bx times x plus 1 plus x plus 1. Okay. And we could either plug in or something that's maybe useful to look at are these highest powers. So on the left-hand side, we have 0x squared, and on the right-hand side, we have -2x squared plus bx squared. So that must mean that b equals 2. We could have also evaluated at other x values, and that would be fine as well. Okay. So let's put our pieces back together. We have that this is going to be, our a is -2 over x plus 1. Our b we found was 2 over x, and our c was 1 over x squared. Okay. All right.